H0 moins 1 minute.
So we are 1 minute to launch. Our very best wishes now to start their journey.
Bon voyage Ariane 6 and bon voyage Amazon Leo.
À tous EDDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Allumage ESR et décollage. La propulsion est nominale. La propulsion est nominale. Pilotage calme. Trajectoire nominale. La propulsion est nominale.
The Ariane 64 rocket.
Passage du transonique. Trajectoire nominale.
Space Center.
Yes, very impressive images.
Journey on board Europe's most powerful version of Ariane 64 yet.
A beautiful sky to see the launch.
La trajectoire est nominale.
Very nice.
Yes, indeed. It's a very, it really is a very wonderful thing to see. The rocket and the sound of the rocket.
Propulsion nominale.
Doing all the work right now, Loïc.
Pilotage toujours calme.
%90 of the first at liftoff.
La trajectoire est nominale.
Each booster carries almost 160 tons of solid propellant, and they will burn in about 2 minutes.
Séparation des ESR. Fin de rattrapage, début du mode barbecue. Trajectoire nominale. Séparation coiffe. La propulsion est nominale. Le pilotage est calme. Trajectoire nominale. La propulsion est nominale. Le pilotage calme. Trajectoire nominale. La propulsion est nominale. Pilotage calme. La trajectoire reste nominale. Propulsion toujours nominale. Pilotage calme. Il reste 2 minutes de propulsion Vulcain. Propulsion nominale. Pilotage calme.
We give the maximum thrust we can expect to have the propulsion of our.
Trajectoire nominale et acquisition de la télémesure par la ESA.
It is, yes. It is inherited from Ariane 5 technology. It has been, of course, improved for Ariane 6 with major optimization. For instance, the nozzle manufacturing has been completely done differently, and we have a gas generator using additive manufacturing, so the very latest technology.
Il reste 1 minute de propulsion Vulcain.
We will burn 154 tons of cryogenic propellant in about 8 minutes. We will reach around 270 kilometers. At that point, we will be able to shut down the engine and separate the lower stage since we don't need it anymore.
A quick word on the top right of your screen. The green line is the trajectory, planned trajectory. The yellow line is the actual trajectory, and the cross is the actual position of our rocket. Below that, you've got our altitude, our distance from the pad, and our speed in kilometers per second. We are tracking the rocket using telemetry. We have ground stations dotted along its flight path, and as the rocket flies over, it sends a signal to those ground stations. So effectively, it's kind of talking to us. It's communicating with us.
Yes, it's really important to have to keep track of the launcher, where it is, how it's behaving, and to do so, the launcher is constantly sending signals to those tracking stations that are on ground, but not only on ground. We have one also in the Atlantic.
Yes, in a boat.
In a boat. The Naval Tracking Station. It's a boat equipped with large antennas, stabilized, of course, in case the sea is a bit rough. And it's a really precious mean of communication that allows us to keep always contact with the launcher.
And this is the sequence now, the separation sequence of the main stage. You can see it there falling away. It's burnt its propellant, that great big tank of fuel now empty and being jettisoned. And you should see on the camera images the engine of the main stage. You can see it there falling away. It's burnt its propellant, that great big tank of fuel now empty and being jettisoned. And you should see on the camera images the engine of the upper stage switching on. The engine is actually on the right-hand side. You can just see it warming up, heating up there, getting redder and redder.
Yes.
Yeah, as it burns. So we are now very much in the next phase of our journey because the upper stage has switched its engine on, and that's an important moment, isn't it?
Yes, always a critical moment, of course, to switch on and off an engine. So right now we are starting the next big steps of the mission. Allow me to say that the images are incredible right now.
They really are, aren't they?
I'm a bit mesmerized. So critical time indeed, and we are now raising again our altitude. We will place the rocket and the satellites onto a kind of intermediate orbit, an elliptical orbit. We will have propulsion with the Vinci engine for 10 minutes, and we will shut it down then, and then we will have a ballistic phase, so no propulsion. We will talk a little bit about this later, but now you can just enjoy the view.
It's quite fun, isn't it? Looking here on the left-hand side of the screen is our real camera images from the cameras on board the rocket, and then on the right-hand side our animation, the 3D simulation of what's been planned for today's mission. So most of the Ariane 6 rocket is actually built in Europe, isn't it? Some of it here in the Ariane group. And the sections are actually transported to French Guiana for assembly at the spaceport. They travel by boat, but it's not just any old boat, is it? It's a really special boat because it's actually got sails, and that's not something that we see very often these days.
Yes, indeed. The name of the boat is Canopé. It has a hybrid propulsion system using both fuel and wind power with its 4 wing sails. And the fact that it uses the wind power enables us to save up to 40% of the fuel we would use with a regular mean of transportation. And it's an important step, of course, to reduce the carbon emission of all the transatlantic crossing that we do for the Ariane 6 project. So the Canopé boat has been sailing all around Europe to collect the different sections of Ariane 6 in the different location of production of the components, and of course carried them to French Guiana for the assembly and the launch day. Canopé has been designed to transport very large but also very fragile components at sea, whether it's rough or calm, and also in the very shallow waters of the Kourou River in French Guiana. It's something like 21,600 kilometers per hour, and for American viewers and British viewers, that would be 13,400 miles per hour.
Okay. And our flight path, where are we flying over?
So we left, of course, the coast of French Guiana. We are across the Atlantic now. We will head towards Central Europe, and we'll go on the other side of the Earth and down to Indonesia and Australia. We will fly over New Zealand as well. We'll catch there another ground tracking station to allow the second boost of the Vinci engine. And then we will fly again towards South America, and that's when the separation sequence of satellites today will happen. And after the commercial mission is completed, we will also have another lap of the Earth with what we call the passivation and re-entry phase. So we will have the launcher upper stage go down to the atmosphere so we don't leave any debris.
Le pilotage est calme.
Oh, it's the schedule of the engine, and the range operations manager says that the piloting is calm. So we have now switched our engine off and reached the first major step, I guess, in reaching this target orbit. We're actually in what we call the ballistic phase. As you mentioned, we're traveling without propulsion. We are coasting without the engine, and we've got a really nice shot there of our satellites attached to their dispenser. 36 satellites, looking a little bit like a corn on the cob.
Yes, if you want so.
Yes, and they will be all separating later from that dispenser, but right now they're still on their way to their separation orbit. And the next ground station to pick us up will be in the southwest of France. It's called Ossagal.
Yes, in the south of Toulouse, in southwestern France. Toulouse, of course, is a great city for aerospace industry, a lot of industrial there. There's also a very interesting exhibition center, which is l'Espace, City of Space. So if you're a space geek or if you are remotely interested in space topics, make sure to pay a visit to this exhibition. It's really interesting.
Yeah, highly recommended, definitely. So we're going to take a break now. We're going to take a break for 45 minutes. That means we'll be coming back to you at about 12:57 GMT, Greenwich Mean Time. That's 2:57 in the afternoon in Paris. That's 9:57 in the morning at the spaceport in Kourou, and 8:57 in Washington. So we'll see you back here then.
Stay tuned.